Namaste, my dear brothers and sisters. The love and blessings of the Mother and Sri Aurobindo to all of you from Sri Aurobindo Ashram Delhi branch. And this session is on autonomic functions. And autonomic functions are those which are not under the control of willpower. And what it means is that we don't have to make an effort for those activities. They just go on their own, which in a way is a blessing. Because just imagine if we have to remember all the time that I have to beat my heart and we forget it for a minute, what will happen? So it's good that we don't have to do anything consciously to keep those functions going. Not only that, these functions are also by and large not strictly dependent on neural activity. For example, if the nerve going to a skeletal muscle is cut, the muscle is completely paralyzed. But if the nerves going to the heart are cut, the heart still continues to beat, which means that they have autonomous activity. They're not only not under the control of willpower, their activity goes on irrespective of our willing it. What the nervous system does, that is the autonomic nervous system, what it does is to modulate the activity, increase or decrease the tempo of the activity. But on their own, the heart muscle goes on beating. The muscles of the gastrointestinal tract keep on propelling the food further. So quite a bit of these autonomic functions go on their own without any effort. So it saves effort, spares our attention for other activities, and also becomes a safety factor because no matter how hard we try, we are likely to forget what we want to do. And if one forgets to perform some essential functions like the heartbeat, you can imagine what would happen. So there's a lot of safety built in here. Not only we don't have to think about doing these things go on even when their nerve supply, even when they are deprived of their nerve supply or the nerve supply is damaged. The nerve supply, what it does is to only increase or decrease the tempo of the activity. Now, we'll understand a bit about these activities from the neurophysiological and neuroanatomical point of view. Here again, we'll start with the spinal cord. And now we'll look at another region of the spinal cord. This is a region that we have not seen so far. And this is neither at the back side nor the front side. It is somewhere in the middle, and therefore it's called the intermediolateral column. Now, the neurons here are the ones which are concerned with autonomic functions. And in this case, what happens is that they are connected to another nerve cell, which then supplies a muscle or a gland. So the heart muscle or the muscle of the gastrointestinal tract, or a gland like the salivary glands or the gastric glands, because these are all activities which are autonomic in nature, autonomous in nature. They go on their own. They're not under the control of willpower. Now, this junction, which is outside the central nervous system, outside the spinal cord, this junction is what is called the ganglion. And corresponding to this nerve cell, which is before the ganglion, is the preganglionic neuron. And the one which is after the ganglion is the postganglionic neuron. So this is the basic organization of the autonomic nervous system. And then, of course, as in the case of any other function, there are influences from the higher regions of the brain. those which affect involuntary functions, those which are concerned with emotions, those which are concerned with willpower, which means even willpower can influence these activities to some extent. So from all those regions, there are inputs, but this is the basic circuitry by which the messages are sent to parts which have an autonomic innervation. Now, in autonomic nervous system, actually, there are two divisions, sympathetic and parasympathetic. And what the sympathetic nervous system does is to provide us sympathy. When do we need sympathy? We need sympathy when we are in trouble or when we are in emergency. And an animal is in emergency when it is threatened by an enemy. And it also is has to be active and excited when it has spotted some food, say a wild animal which lives on hunting. If it has spotted a smaller animal which it can hunt, again it is too excited. So those are the type of situations in which the sympathetic nervous system becomes more active. So it is the division that comes into play during fight, flight, and fright type of situations. When one has to put up a fight, flee from the situation, or when the person is or the animal is frightened. So fight, flight, and fright reaction. So that is the situation. These are the situations in which we need some sympathy, and the sympathetic nervous system provides that sympathy by modulating the activity of these different parts of the body, which are autonomous functions. It modifies the activity of these parts of the body, uh, steps the activity up or down, depending upon what the body would need in that particular situation. On the other hand, the parasympathetic division is more active when we are at rest, when we are relaxed, when we are at peace. And therefore, in many ways, the effects of the parasympathetic activation are opposite to those of sympathetic activation, because our requirements are somewhat opposite in these two situations. When we are in an emergency, or when we are in difficulty, or when we have to exert physically, those requirements are different as compared to the requirements of the body when we are at peace, when we are relaxed. And the type of activities which we also perform are different in these situations. When we are uh, when we have to when we are in a situation that requires sympathetic activation, those are the situations in which physical exertion is also generally required. Whereas when we are at peace and relaxed, it's another type of activities, like say for example uh, having food, digesting food, reading. Those are the type of activities which we can indulge in when we are at peace, when we are relaxed. And that is when the parasympathetic division is more active, and it makes those changes in the body which will make it easy for us to meet the requirements of that peaceful situation, and gives the body, in fact, some rest, so that the type of activation which was there in sympathetic is no longer required. It comes down. And now let's look at the neural organization of these two divisions. Is there any difference? We saw the general organization of the this part of the nervous system, that is the preganglionic neuron and the postganglionic neuron and all that we saw. But is there any difference between the two divisions? Now, this is the preganglionic neuron, this is the postganglionic neuron, and this is the ganglion. Now, this is sympathetic. In case of parasympathetic and these sympathetic division, uh, for this, these neurons are located in the thoracolumbar part of the, that is the chest and the abdominal part of the spinal cord. The spinal cord is a long thing starting right from the neck going up to the lower part of the back. So it is in the chest and the back part that we have neurons, which are this and this. The sympathetic ganglia, this is a ganglion. There are several of them in this region, and they form a sort of a chain. So this is the chain of sympathetic ganglia, which one can see on dissection. And there have been sort of uh, comparisons made of the sympathetic chain on the right side and the left side with the Ida and the Pingla. Now, one doesn't have to bend over backwards to find some sort of a parallel. In those Ida and Pingla, those nadis which have been seen in the subtle body. They cannot be seen on dissection. And the comparisons are far-fetched and inappropriate, so we'll not get into that. But this is the sort of division, that this is the sort of arrangement which we can see structurally under the, when you dissect a body, and further the details you can see under a microscope. Now, what is the parasympathetic like? This is sympathetic. Now, in case of parasympathetic, this is the preganglionic neuron. The postganglionic fiber is very short. The ganglion is located within or very close to the organ that is innervated. So this muscle or gland which is being innervated, this ganglion is either within it or very close to it. The postganglionic fiber is extremely short. So this is one major difference. And the neurons, the preganglionic neurons for the parasympathetic, are located in the craniosacral region. That is in the brainstem. That is that part of the brain which is the lowermost, or in the sacral part of the spinal cord. So that is where these neurons are located. So the supply all over can be from these limited regions, because the fibers can ascend up and descend down. So we do not have both sympathetic and parasympathetic neurons of this type throughout the spinal cord. These are in the lumbosacral region and these parasympathetic in the craniosacral region. So they are in different parts. But anyway, that is a minor thing. The important thing is that here the postganglionic fiber in case of parasympathetic is very short, and the ganglia are therefore located either within or very close to the organ. Now, how about the neurotransmitters? That is the chemicals by which the message is conveyed. The preganglionic neuron conveys the message to the postganglionic neuron by using the neurotransmitter acetylcholine, which you are familiar with. This is the chemical which is used also by the neurons which supply skeletal muscles. They release acetylcholine to convey the message to the muscle. Here, the same neurotransmitter is used for conveying the message to the postganglionic neuron. But in case of sympathetic and parasympathetic, the chemical released by the postganglionic neuron is different. In general, the sympathetic postganglionic neurons release noradrenaline, whereas the parasympathetic neurons they release acetylcholine also at the postganglionic nerve ending. So the neurotransmitters are different in case of these two. Now I'll introduce a little more complication here and delete the parasympathetic. And show you one more structure. Now, there is a structure in the body which is essentially a part of the sympathetic division, but where instead of there being a postganglionic neuron, there is only a cell, and this cell releases a substance very similar to noradrenaline, that is adrenaline, into the bloodstream. Like all parts of the body, the part which has this type of cells also has a blood supply, and these cells release a substance very similar to noradrenaline, which we call adrenaline, directly into the bloodstream. So you can see the arrangement is very similar to sympathetic, except that in this cell within this organ, this cell within this organ is behaving, functioning like the postganglionic neuron here. Now, which is this organ? Some of you might have already guessed it. This type of cells are present in the adrenal gland, in the adrenal, inside of the part of the adrenal gland, which we call the adrenal medulla. So it is in the adrenal glands that we have this type of cells, and that's why the substance which is poured into the bloodstream is adrenaline, and the substances which are poured directly to the bloodstream like this are called hormones. So adrenaline is a hormone. So here adrenaline is a hormone, here noradrenaline is a neurotransmitter. Neurotransmitter because it is being released by this neuron transmitting a message to the part which is innervated. Here, the substance is being poured directly to the bloodstream. It can go anywhere, all over the body. Now, why this difference in the arrangement? Why in sympathetic we also have this type of an arrangement, which we don't have in parasympathetic? That is easy to understand because when a person is in an emergency, some change in activity may be required in the heart or in the lungs. And for that, this type of a specific messaging, that is message which is delivered to a specific part of the body is necessary. But then along with that, there are many changes which will be required throughout the body, generalized sort of changes. For example, the stored glycogen and fat will have to be broken down, and so that the stored fuel can be released for being used during the emergency when the person is or the animal is not eating. But at the same time, the reserves have to be used for getting that extra energy which is required during the effort. Now, so generalized changes are more necessary here than over here. However, all these changes also need not be as general as they look just because it is going all over the bloodstream, because along with the chemical, we also need appropriate receptors. So places which have those receptors are the places where this activity will change. But all the same, this can have far more generalized effects as compared to the parasympathetic, because when the sympathetic division is activated, not only are many different parts of the body getting specific messages through these postganglionic neurons of the sympathetic system, but simultaneously, there's also activation of the adrenal glands, the adrenal medulla, which in turn releases adrenaline, which circulates all over the body. Now, for noradrenaline and adrenaline, I might also mention there are two types of receptors. For noradrenaline and adrenaline, there are two types of receptors, alpha and beta. Noradrenaline is primarily an alpha receptor activator. Adrenaline noradrenaline has an affinity for alpha receptors. So organs which have alpha receptors are the one where activity will change as a result of this type of activation. Whereas adrenaline has an almost equal affinity for both alpha and beta type of receptors, and therefore it will activate those organs, which will bring about a change in the activity of those organs which have either alpha or beta type of receptors. Why I mentioned this was because you might have heard of beta blockers being used. Beta blockers being used as treatment. Now, we are blocking the beta receptors, which will prevent the action of adrenaline. For example, the heart gets activated by adrenaline, the heart rate goes up. If we use these beta receptor blockers, then the heart rate will not go up like that, because those blockers will prevent the action of adrenaline on the heart. Okay. So now with this background, let's turn to the PowerPoint. I would like to dedicate this session to these two gentlemen, Professor B.K. Anand, who was my teacher in the Department of Physiology, also the founder head of the Department of Physiology at the All India Institute of Medical Sciences. And Professor P.K. Gujral, Professor Pramod Gujral, who was my teacher in the pharmacology department. He was a pharmacologist and passed away very recently. Why I'm doing that is because much of what I'm speaking today, and the way I'm talking about it, is based on the way these two people taught me. I can more or less sort of feel one of them speaking through me. For example, when I said that the sympathetic and the parasympathetic do what the body needs in that situation, and I'll say many such things as we go along, is exactly the way Dr. B.K. Anand used to speak. And when I said that the parasympathetic division has very short postganglionic fibers, and the ganglia are situated either within or very close to the organ innervated, I can almost find that I'm just echoing the way Professor Pramod Kumar Gujral used to speak in pharmacology. So the clarity that I have today on this subject is primarily because of these two persons, not because of what I have read in the books. And although I mean, it is now around how many years? Professor B.K. Anand was teaching me all this in the year 1966. So it's more than 55 years, around 55 years ago that these people taught me, and these two persons. And still, it's basically a repetition of that same, not only facts, but the same style of presentation, which I'm just sort of more or less repeating. Now let's see what the effects of sympathetic and parasympathetic activation are on different parts of the body. Now the sympathetic division comes into activity when one is exerting. Now when one is exerting, would one like the heart to beat faster or slower? Naturally faster, because there is a greater need for blood supply in the skeletal muscles. And therefore the heart starts beating faster and more forcefully. The heart rate goes up, and the force with which the ventricles beat, that also increases as a result of sympathetic activation. On the other hand, what would be the needs of the heart, how much the heart needs to be active when we are at peace and relaxed? We would not need that much activity of the heart. So we do not need a very fast heart rate. We need a slower heart rate. The heart can relax a bit, take rest, beat less forcefully, beat less frequently. And that's exactly what the parasympathetic does. How about breathing? Now, the activity of the heart and the breathing are closely related, because the heart takes the blood, helps in taking the blood to different parts of the body, whereas breathing ensures that the blood that goes to different parts of the body has enough oxygen and does not have accumulation of carbon dioxide. And therefore, when we need a greater activity of the heart, that is the time we also need greater activity of the respiratory system. And how will the person be able to breathe more? By having a faster rate of breathing, by having deeper breathing, and also by the airways opening up so that air can easily enter and come out. The larger amounts of air can enter and come out without much resistance. And that's exactly what the sympathetic does. It increases the rate of breathing, it increases the depth of breathing, it opens up the airways. All these things would not be necessary when we are at peace and relaxed. And bringing down all these activities, bringing down the respiratory rate, bringing down the depth of breathing, and narrowing down the airways a little, that is exactly what the parasympathetic does. What about the gastrointestinal tract? When one would eat, when one is at rest, or when one is running away from an emergency, naturally at peace. When we are at peace, when we are relaxed, that is the time when we would like to eat. And associated with eating are functions of the gastrointestinal tract, like the movements of the gastrointestinal tract, secretion of different juices of the gastrointestinal tract, the saliva, the gastric juice, the pancreatic juice, and so on. And all these juices are, the secretion of all these juices is activated by the parasympathetic division. We want this type of activity shut down during when we are in an emergency, and the activities, all these activities get shut down during an emergency. So that's exactly what happens as a result of sympathetic and parasympathetic activity. Sympathetic reduces the motility and secretion of the gastrointestinal tract. Parasympathetic increases the secretion and motility of the gastrointestinal tract. Apart from secretion and motility, another function of the gut is located at the lower end, and that is defecation. Now, when one would like to pass the stool, again, one is at peace and relaxed. Now, here, what is it that we will require this part of the gut then to do? When we are at peace, when we are relaxed, when we want to pass the stool, the rectum and anal canal, they should contract, and the sphincter, that is that ring-like muscle which is guarding the opening, that should relax. And that is exactly what the parasympathetic does. So you can see that it's not that parasympathetic always brings about contraction, because when it comes to the stomach and intestines, for propelling the food further, parasympathetic makes these muscles contract. But when it comes to the rectum and anal canal, for passing the stool, we require the relaxation of, the contraction of these, yes, the contraction of these. But we want relaxation of the sphincter. So while I'm in the rectum and anal canal do contract, like those parts of the gastrointestinal tract where propulsion has to take place, the opening, the sphincter, that ring-like muscle which guards the opening, that relaxes. So the same parasympathetic can bring about contraction in the rest of the gut, but relaxation in the opening. So whether it will be contraction or relaxation is need-based, not that sympathetic will always do one thing and parasympathetic always the other. On the other hand, what does sympathetic do? It reduces the motility, it reduces the secretion, and it also relaxes the rectum and anal canal, and it leads to a contraction of the opening, that is the sphincter. Something similar applies to the urinary bladder. Again, we want to pass the urine when one is at rest and relaxed. Therefore, it's the parasympathetic which helps in contracting the bladder and relaxing the sphincter, that opening which lets the urine flow out. You might say that sometimes some animals pass urine when they are very frightened. Even can happen occasionally to human beings also. Now, that is a paradoxical response, and the body has those type of paradoxical responses also built in. In general, sympathetic, when we are tense, when we are in emergency, the bladder relaxes and the sphincter contracts. But This paradoxical mechanism comes into play as a defense mechanism in cases of extreme fright, because that can then distract the attention of the enemy. If suppose there's a small animal which is trying to run away from an enemy, then if it passes urine, then that might distract this, slow down the animal which is trying to hunt it, and this would be therefore be a protective response. So the body is built in such a way that whatever the body needs, that will happen at the right time, and there's nothing sort of sacrosanct that sympathetic will always do this or parasympathetic will always do this. If you just try to think what is it that the body needs at a particular moment, then you'll find that is what the sympathetic or the parasympathetic do. Then how about blood flow to different parts of the body? When one is in an emergency, we need more of blood flow to the muscles. And that's what exactly happens. Sympathetic neurotransmitters like noradrenaline, uh, in general, bring about a constriction of the blood vessels. That would actually reduce the blood flow. But then we want increased blood flow in the muscles when one is in an emergency. So how nature has arranged that is that there are acetylcholine releasing sympathetic fibers in skeletal muscle. That is, acetylcholine opens up these blood vessels. Noradrenaline would close them up. Adrenaline can close and constrict both. Alpha receptors would constrict, beta receptors would relax. So we have the beta adrenergic receptors and cholinergic receptors. The receptors which have an affinity for acetylcholine, increasing the blood flow through the muscles during sympathetic activation. And where is it that we need less blood flow, therefore? Because blood flow cannot be increased all over the body. That will lead to a fall in blood pressure. So if the blood flow is required more in the skeletal muscles during exertion, then wherever that blood flow is not required, excessive blood flow is not required, at those places, noradrenaline will close the blood vessels, the blood flow will reduce. And one of those areas would be the gastrointestinal tract, for example. In the gastrointestinal tract, the blood flow reduces, whereas to the muscles, the blood flow increases as a result of sympathetic activation. Parasympathetic does just the opposite, because it is during the peaceful and relaxation that we eat, and that is when we need greater blood flow to the gastrointestinal tract. How about the eyes? When an animal is in an emergency, then even if it is dark, it would be helpful to be able to see as much as is possible. Even the little bit of light that is there should be able to enter the eyes. And therefore, for that, the pupils need to open up. So that's exactly what the sympathetic does. It widens up the pupils. The sympathetic dilates the pupils, opens them up further, and it also leads to a relaxation of the ciliary muscles, so that the lens is not in a position of accommodating for near vision. Instead, it is accommodated for distant vision. So one will be able to see a long distance with poor light as a result of sympathetic activation. Whereas one may like to read when one is at peace and relaxed, and that's what the parasympathetic does. It helps in constricting the pupil. It makes the pupil narrower, because that improves the focusing. And it also leads to a contraction of the ciliary muscles, which will fatten up the lens a bit and makes it more suitable for near vision. How about sweating? Sweating is often, again, a type of a response which is required in heat. Heat is a type of stress, but then it is a type of stress in which we require a localized activity. In general, sympathetic activity, when we have sympathetic activation, we need generalized activation all over the body. The heart beating more forcefully, breathing increasing, the airways opening up, and the rectum and the bladder, they taking rest and not letting the urine or the stool flow out. So we need the pupils widening and so on. increased blood flow in the skeletal muscles. So we need a generalized activity and metabolism, breakdown of glycogen and the fat reserves. So the generalized activity is required. But in case of heat stress, we do not need that type of a generalized activation. We need only activity of the sweat glands. And we find that, again, nature has ensured that by having in the sweat glands acetylcholine releasing nerve endings. So they're sympathetic, but they release acetylcholine that leads to an increase in the blood flow to the sweat glands and increases the amount of sweating. So acetylcholine in general relaxes the blood vessels, and increased blood flow will increase the activity, or increased activity needs increased blood flow, whichever way you look at it. So that will lead to, and both are true to some extent, increased activity increases the blood flow, and increased blood flow enables that increased activity. So that is what happens in sweat glands. Sweat glands become more active when it is hot, and that is brought about by the activation of acetylcholine releasing sympathetic nerve endings in the sweat glands. What does parasympathetic do? What parasympathetic does is to uh, give some sweating only on the palms, not all over the body, but only palms. So palmar sweating increases, not generalized sweating as a result of parasympathetic activation. And metabolism, sympathetic increases the breakdown of glycogen uh, so that glucose is released. Glycogen is the storage form of glucose. Fats are broken down so that fatty acids are released and can be used as fuel. That is what the sympathetic does to the metabolism. Parasympathetic has no major effect on metabolism. So you can see the effects of sympathetic and parasympathetic can be predicted. One doesn't have to sort of look at a table in the book to find out what sympathetic does to any of these functions or to parasympathetic does. What they do is what you think will is required by the body. You don't have to look up a book. You don't have to try to remember it. You'll know it all the time if you just think, what is it that the body would need? What is the type of function that we would perform when we are at peace and relaxed? What is the type of function we would indulge in when there's an emergency? And what will be the requirements of the body in that situation? And you'll find that that is exactly what either the parasympathetic or the parasympathetic does. Sympathetic will do what is required by the body when we are in a state of emergency, and parasympathetic will do those, bring about those changes in the body which the body needs when we are at peace and relaxed. This is exactly the way Dr. B.K. Anand used to speak in 1966, and I'm more or less repeating that. Now, why do we need both sympathetic and parasympathetic divisions? One might say that sympathetic increases the heart rate, then you can reduce it by the sympathetic shutting itself up. So if a sympathetic switch is switched off, if this sympathetic is turned off, that will reduce the heart rate. So you can achieve an increase in the heart rate and decrease in the heart rate both by one single mechanism. Sympathetic activity increasing will increase the heart rate. Sympathetic switching itself off will reduce the heart rate. So you can increase the heart rate and reduce the heart rate by just one division. Why do we have these two divisions doing opposite things at most places? Now, one can understand that easily by thinking of a car. In a car, we have both a brake and an accelerator. What the brake does is to slow down and stop. The accelerator increases the speed. Why do we need both? Because if we have only the accelerator, if we press on it, the car will run faster. If we don't press on it, the car will start slowing down. So we can increase the speed and slow down the speed by using only the accelerator. Why do we need a brake? We need a brake because even the best driver sometimes needs to stop much faster than is possible by just not working on the accelerator. And therefore, we do need also a brake. And the two together help us in achieving a change in the speed much faster than would happen if we had only one of these. And therefore, by having these two different controls, we give better control, just like the brake and the accelerator in a car. Now, what is tone in relation to autonomic activity? In case of skeletal muscle, a weak contraction is present all the time, and that is what we call the tone. The same is true of also of autonomic activity. Some parasympathetic activity and some sympathetic activity is present all the time. And that is the tone of the autonomic activity. Why do we have tone in all these places? Skeletal muscle and sympathetic and parasympathetic? Because if something is already a little active, its activity can be stepped up or brought down more easily than if we have to activate it from a complete standstill. We can understand that intuitively. Happens in aeroplanes also. They consume maximum energy during takeoff and during landing. Once it is high up in the sky, very little energy is required, and therefore they work on very little fuel. So maximum energy is required to initiate or to stop, not for continuing the activity. So if some activity is already continuing, then modulation of activity is much easier. And probably that is why here also in skeletal muscle as well as in autonomic functions, we have a certain tone, that is a certain basal activity which is there all the time. Weak activity is going on all the time in both sympathetic and parasympathetic. So this is the steady activity when neither has been specifically activated. Neither sympathetic nor parasympathetic has been specifically activated, and yet there is some activity of both all the time. Now, what is autonomic balance? Balance, follows from the tone. That is the degree to which we have sympathetic tone and the parasympathetic tone. The balance between the two is what we call autonomic balance. So the balance between sympathetic and parasympathetic tone. And how do we know which of the two is dominant? One way to know it is in case of animals, if you deprive the animal of both sympathetic and parasympathetic, what happens to the heart rate? If the heart rate increases, it means that the parasympathetic tone was dominant over the sympathetic tone. And in human beings also, to some extent, we can judge it from the resting heart rate. To some extent, we can judge it from still more sophisticated measurements like the heart rate variation. From that, we know which of the two is dominant. And this is of some significance to those who are on the path of yoga, because yoga increases parasympathetic tone. Because we are more at peace, more relaxed, it increases parasympathetic tone. And parasympathetic dominance is one of the results of yogic practices. So can autonomic balance change, and can it be changed, and should it be changed? Yes, it can change from time to time. The same person may not have the same autonomic balance all the time. And it can be changed through activities like the yogic practices. And should it be changed? Yes, it seems to improve our health in general if we have a higher parasympathetic dominance. So autonomic balance of an individual keeps changing, can be changed, and it is desirable to change it towards parasympathetic. More peaceful, more relaxed. The type of results we get in the body seem to keep us healthy. Now, it's often said, and it's correct, that alternate nostril breathing improves parasympathetic activity and also helps in achieving good autonomic balance. And this is here you can see the fingers in Nasika Mudra, the two fingers just next to the thumb folded, so that the nose will now fit snugly between the thumb and the ring finger. And then one can close one nostril at a time and have alternate nostril breathing. That is, out and in, change the nostril, out and in, change. And what happens is that when we are breathing in through the right, there is sympathetic activation. Breathing in through the left leads to parasympathetic activation. In alternate nostril breathing, we are breathing with both alternately, and therefore we get a balance. But suppose one wants to selectively stimulate parasympathetic, then one should be breathing in through the left only, and that is what we do in Chandra Anulom Vilom or in Chandra Bhedan Pranayama. But then sometimes one also needs to stimulate only the right. For example, it helps in losing weight. Then we breathe in through the right and breathe out through the left, which is Surya Bhedan Pranayam. Breathe in through the right and breathe out through the right, that is Surya Anulom Vilom. So one can have variations, but for normal purposes, we have the usual Nadi Shuddhi Pranayam, that is alternate nostril breathing. Now, here there's a little application also which one can have. Suppose you are feeling very cold and you want to generate some heat. For that we need sympathetic, because release of adrenaline increases the activation of the heat generating mechanisms, and therefore sympathetic activation is helpful. Now, suppose you're gone somewhere not sufficiently protected against cold and you're feeling cold. You can start right nostril breathing. It will generate some heat. You'll feel less cold. You'll feel that you are feeling quite okay. Now, but it will look funny sitting there and doing this, taking your hand towards the nose and doing this type of breathing in and breathing out through the right and so on, or breathing in through the right, breathing out through the left all the time, which means using only the right nostril for breathing in. It will look very funny. Now, to some extent, this control, whether you breathe in through the right or through the left, can be exerted even without using the fingers. You just need a little practice. You'll try it and you'll find that willfully you can direct the air in such a way that it enters only through the right all the time. And if you do that, sitting there quietly, after some time, you'll find you'll not feel cold. At the end of the session, let me share with you this little a few verses from the Gita. This is in the very first chapter when when Krishna and Arjuna are in the battlefield, and Arjuna has asked Sri Krishna to take the chariot in the middle of the battlefield so that he can have a good look. And when he finds that on the side of the Kauravas, that the people whom he is fighting against, amongst them are his own close relatives and teacher and so on, he doesn't want to fight. And he tells Sri Krishna, 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 now as I look on these my kinsmen arrayed for battle, my mouth is parching, my body trembles, my hair stands upright, my skin seems burning, the bow gandi slips from my hand, my brain is whirling round and round, I can stand no longer. This, in a way, is the type of feelings, the type of bodily changes that one experiences when the sympathetic is activated. So it's a high level of sympathetic activation, which in a way these verses are describing in the first chapter of the Gita. And as a result of the message of the Gita, Arjuna is at peace. All that sympathetic activation is gone. He's able to fight and fight without getting the type of sympathetic activation which he initially experienced, because now he's doing it as an instrument of the divine without any attachment to the fruit. Suggested reading this popular book, The Human Machine, these two textbooks, Fundamentals of Physiology, and a much more elaborate textbook, Understanding Medical Physiology, Sri Aurobindo Ashram, Delhi branch, a place to which you are all most welcome anytime. For any questions or comments, please drop an email to yes@yesspirituality.com. Gratitude to the Mother and Sri Aurobindo for making these sessions possible. And thank you all for being there. Any questions? It's been a long session. I didn't anticipate it will go on for so long.
Namaste, sir.
Namaste, Mukundji.
How about the vagus nerve
Yes,
and
sir.
its connections with the parasympathetic system, and how can we retrain vagus nerve to be able to seek autonomic balance?
Yes, vagus nerve is a major parasympathetic nerve supplying almost everything in the thorax and abdomen, and therefore it's considered sort of the key to parasympathetic activity. And one doesn't do anything specifically for the vagus. If one does the yogic practices, stays at peace most of the time, one is able to achieve that equanimity, the vagus will become more active. So we are working on the sort of R cells And in fact, the chain goes something like this. If one is working without expecting any results, basically to live a more meaningful life, uh, which is what yoga and spirituality are basically about, one starts feeling, and so your whole horizon is so much wider and deeper that when you are living with that attitude, then uh, you are active, you are engaging with in action and engaging with the world, and yet you're not affected by anything. You can maintain equanimity. And when that starts happening more and more, one finds that the parasympathetic becomes more active, and that's how parasympathetic tone is improved. But then, apart from that, some physical practices also do help. And I mentioned only alternate nostril breathing for autonomic balance. But in general, all these activities, particularly the relaxing activities amongst them, would help. Uh, In fact, it has been found that in even a few weeks or months of practice, the experimental studies are not very long most of the time. A few weeks or months of these practices improves parasympathetic dominance.
Okay, thank you, sir.
So, I mean, when in only these practices done, even in isolation, as it happens in experimental studies, can do it. Because in experimental studies, very often it is done, half-heartedly. The person is not necessarily on the yogic path or the spiritual path. I said that so many volunteers were recruited for the study, and then they were given this protocol: 1 hour of these practices every day, physical practices, this much time for meditation. At the end of 4 weeks or at the end of 2 months, these measurements were done again, and this is the difference that was found. Now, truly speaking, yoga was not designed for this purpose. In yoga, we don't recruit people. In yoga, uh, either people come voluntarily seeking for something deeper in life, or they're initiated by a guru. In yoga, we don't recruit people. Secondly, it is not restricted to just 1 hour of physical practices and half an hour of meditation every day. It doesn't have a protocol. And the aim is not to bring down the resting heart rate. The aim is something much higher and wider, and these things happen as a byproduct. But even if something done half-heartedly in experimental studies can achieve so much, one can imagine how much more would be possible if it was done the right way, uh, starting with the right motives and not bothering about what is happening. It will happen anyway.
It will happen. Yes, sir. Thank you, sir.
I had a question. Sorry, Mukunji, you had a
No,
question?
no, it's okay. Madam, yes, please.
No, you
After.
can complete. You
No,
can
no,
complete.
I have completed. Thank you, madam.
Thank you. You said breathing to the left is parasympathetic, right?
Yes.
And you also mentioned, and for our digestion and everything, while we eat, for secretion of all the enzymes required for digestion, that happens when we are in the parasympathetic um, state. So, does that mean that while you're eating, it is better to breathe through your left?
While we're eating, we should.
While you're eating, it will be. I mean, if I've heard that it alternates, the breathing alternates between right and left every 1.5 hours. And if you're eating, it is better to breathe through your left or right. Which one would be better? As
No, actually, it will be difficult to concentrate on breathing while one is eating. What is important is to eat uh, in a state of peace, in a peaceful atmosphere. And
Mhm.
in that we understand. I mean, if one eats when one is excited and tense after a heated argument with somebody, the mouth is dry because sympathetic activation reduces salivary secretion. The mouth becomes dry, and one doesn't feel like eating because the stomach is actually not receiving it properly. So the body tells us that this is not the right time to eat. But if we still force ourselves to eat, the digestion is likely to be delayed and poor. So that will happen. So that's why we try and build up a conducive atmosphere. Firstly, I mean, we should be not eating immediately after a heated argument or exercise when sympathetic has been activated. Give a little gap. And then the usual practice of not talking much while eating, or talking at least calmly, and Also, praying before eating, praying at the end of eating, all these things help in improving the parasympathetic tone and would improve the digestion. So far as the alternation is concerned, yes, throughout the day, there is an alternation of nostril dominance and left nostril dominance. And one can try that also, experiment. One would find that those who are on the path of yoga, if they measure, say, every 1 hour, the dominance, which nostril are they breathing predominantly through, on the whole, probably over a period of 24 hours, they find more of left nostril than of right nostril breathing. One can make that out by which nostril one is breathing through more, because we are breathing through both all the time. But if someone applies if presses or squeezes the right and then tries to breathe, and then the left, and one finds that it's a little easier on one side than the other. So the side on which is the breathing is easier, that is the side which is dominant at that time. And it keeps changing every hour or two, as you said. So when one does it every 1 hour, for even 17 to 18 hours of the waking period, and does it for a few days, one would know whether one has sympathetic dominance or parasympathetic. And also, if one compares different people, those who are more peaceful, more relaxed because of yoga or otherwise, they are the ones who are likely to have more of parasympathetic dominance. That is, they are on the whole spending more time during these 24 hours having the left nostril dominance than right nostril dominance.
Okay. Thank you.
Thank you. Thank you, sir. Thank you, madam.
Any other questions? Any questions in the chat?
No, there are no questions in the chat.
Thank you. Thank you, Divya, and thank you, everybody.
Thank
And
you.
we close with a moment of silence.